piece of apparatus is going to be the mass spectrometer. Now here's a diagram of a mass spectrometer, and there's 5 processes that have to go on. The first one is your sample atoms have to be gaseous, so its vaporization is the first stage. Then once you've got your gaseous atoms, you have to ionize them. Once you've ionized them to produce 1+ ions, you have to accelerate your 1+ ions. Then you have to deflect your 1+ ions, and then you have to detect your 1+ ions. So they're added in the gaseous state. So our gaseous sample atoms go in, and now they are going to be ionized. Now they're ionized by this beam of electrons which are high energy and fast moving and are being fired from the electron gun. So our sample atoms are bombarded by these fast moving high energy electrons which knock out electrons from the sample atoms, producing 1+ ions. When an electron is removed from an atom, the proton to electron ratio increases, which means the remaining electrons in the ion are attracted more strongly by the nucleus. Now, so therefore, in order to remove a second electron from our Ne+, the electron gun would be requiring more energy and the electrons would have to be moving faster in order to be able to knock out a second electron. Now, the positive ions that are formed, they get accelerated. And they get accelerated by passing through an electric field or between charge plates. Now there must be a vacuum in the apparatus because otherwise particles of gas or air will collide with the ions and deflect the ions. So the ions don't move down the mass spectrometer in the direction that we wanted them to go. Now the cations are deflected by using a magnetic field. The mass, and the net charge. So the magnetic field starts off weak. And we can see the ions there are not deflected. So the magnetic field strength increases, which causes more deflection. So there's a little bit of deflection there. Increase the magnetic field again. More deflection. Increase the magnetic field strength again. And again. And again, until the magnetic field strength is just right so the ions enter the detector. When it increases even more, they no longer enter into the detector. It measures the mass to charge ratio of the atoms present in the sample and the peak heights, giving their relative abundance or percentage abundance. The Na23+, because it's got a lower mass to charge ratio than the chlorine 35+. Now for this one, it's going to be the 2+ ion, because it's got a lower mass to charge ratio. That's 11.5 because it's 23 divided by 2. Ions hit the detector and generate an electric current. Now the greater the current, the greater the number of ions of that isotope and the higher the abundance. So electrons flow to the positive ions, generating an electric current. The greater the current, the greater the number of ions of that isotope, and the higher the abundance.